This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 3, Lesson 4. Bolted and riveted joints and shear. We leave welds behind and pick up the other great family of mechanical attachments, bolts and rivets. When a bolted lap joint carries a load across the faying surface, it can fail in 4 completely different ways. The bolt can shear, the plate can tear across the hole, the bolt can crush the whole edge, or a block can shear out to the free edge. 4 modes, 4 different areas, and the exam trap is reusing one area for all of them. The rule for the whole lesson: check every mode, and the one with the lowest capacity governs. Here's the problem. A lap joint carries a static shear load through a single bolt. You're given the plate thickness and width, the bolt diameter, and the edge distance to the loaded end. You're also handed 4 allowable stresses, 1 for each mode. Check all 4 failure modes, find each mode's safe load capacity, and name the one that governs. The handbook prints the 4 areas. The allowables are supplied as data. Concept 1. 1 joint, 4 ways to fail. The handbook lists 4 candidate modes for a shear connection. 1. The bolt or rivet shears across the faying surface. 2. The plate ruptures in tension across the reduced section at the hole. 3. Bearing. The bolt crushes the hole edge. 4. Tear out. A block shears out to the free edge behind the bolt. Check all 4. The lowest capacity governs. And note the section treats bolts and rivets identically. Concept. Where each mode lives. Top. The side view. The bolt crosses the faying surface in single shear at marker 1, and it presses on the whole wall in bearing at marker 3. Below, the plan view of the lower plate. Marker 2 is the net section, the plate width minus the hole, where rupture runs. And marker 4 is the tear-out block, the bolt drives toward the free edge, shearing on 2 planes over the edge distance A. 4 modes, 4 locations, and as the next slide shows, 4 different areas. Concept. The heart of the lesson. Every mode is F over A, only the area changes. Bolt shear uses the bolt cross-section, pi over 4 times d squared. Rupture uses the net area of the thinnest member, the width minus the hole, times the thickness. Bearing uses the projected area, thickness times diameter, not the round bolt area, and not the curved surface. Tear-out uses 2 times TA, and that factor of 2 is the 2 shear planes. One more piece of mechanics. A double shear splice gives the bolt 2 shear planes, so mode 1's area doubles and its stress halves. Same formula, twice the area. Setup. 4 areas, 4 capacities. Work each mode on its own, then compare. A mode's capacity is its allowable stress times its own area, and the smallest capacity governs the joint. The table holds the geometry: load, bolt diameter, plate thickness and width, edge distance, plus the 4 allowable stresses, 1 per mode. Notice the bearing allowable is much higher than the others. That gap is why you must compare capacities, not raw stresses. Solve. Part 1. The 4 areas and stresses. The bolt cross-section is about 200, giving a shear near 100. The net section is 440, giving a rupture stress of 45.5. The projected bearing area is 160, the smallest, so bearing stress is the highest at 125. And the tear-out area, 2 planes, is 600, so tear-out is the lowest at 33. By raw stress bearing looks worst, but stress alone doesn't pick the governor. Solve. Part 2. Capacities pick the governor. Multiply each mode's allowable by its area. Bolt shear caps at about 24, rupture at 66, bearing at 48, tear-out at 54. Bearing carried the highest stress, but its allowable is high, so its capacity is comfortable. Bolt shear is the weakest link at 24. It governs, even though its stress was lower than bearings. The applied load sits below that, so the joint is safe with a factor near 1.2. That inversion is exactly why you compare capacities, not stresses. The answers. 4 areas, 201, 440, 160, 600, give 4 capacities, 24, 66, 48, 54. The governor is the lowest, bolt shear at 24, and the applied load gives a factor of safety near 1.2, safe. If you need more margin, attack the weakest link. A bigger bolt lifts the governing shear mode first. Fixing a mode that wasn't governing buys nothing. Traps. 5 ways the check bites. 1. The signature miss, reusing one area for all 4 modes. Each owns a different area, so reuse 1 and 3 answers are wrong. 2. Net versus gross for rupture. Subtract the whole from the width and use the thinnest member. 3. The bearing area is the projected rectangle, thickness times diameter, not the round bolt area and not the curved surface. 4. Don't drop the 2 and tear out. There are 2 shear planes. 5. The subtle one. Don't rank by stress. The highest stress isn't the governor. Compare capacities. And the bonus. A double shear splice doubles the bolt's shear area and halves its stress. Quick recall. 4 modes, all F over A, each with its own area. Bolt shear uses pi over 4d squared. Rupture uses the net width minus the hole times thickness. Bearing uses the projected thickness times diameter. Tear out uses 2TA. A mode's capacity is its allowable times its area, and the lowest capacity governs. Bolts and rivets take identical checks. Golden rule. 4 modes, 4 different areas. Check all 4 and let the weakest link govern. Next up, Lesson 5. Fastener groups in shear. Here we sized a single fastener, but real brackets bolt on with a pattern, and an off-center load shares out unevenly. Lesson 5 extends single fastener shear to groups. Find a centroid, split the load into a direct shear on every bolt, plus a moment-driven secondary shear, and find the most heavily loaded fastener. Everything's at peprepengine.com. Cheat sheet, work solution, and a quiz attached here.
The full study guide, with every equation and common exam trap, is free at peprepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.